Okay, here we go. This will be lesson number 3 of the chapter. So our last class, remember we talked about this construction. We made H and K parallel, and we talked about the so what's or the consequences of those two lines being parallel, cut by transversal T, and the formation of those 8 angles. And if you remember, right, if two parallel lines are cut by transversal, then we got 3 main consequences, 3 main ones. There were a couple more, but they were minor ones. But the 3 main consequences were corresponding angles are congruent. Remember, that's angles 1 and 5, 3 and 7, 2 and 6, and 4 and 8. Alternate interior angles are congruent. That would be 3 and 6 and 4 and 5. And lastly, same side interior angles are supplementary. In other words, the measure of angle 3 plus the measure of angle 5 equals 180, and the measure of angle 4 plus the measure of angle 6 equals 180. Those were the 3 main consequences. I made 2 of those red to show those are the congruent ones, and the one in blue, that's the supplementary one. We had a couple other ones, but they were minor. So the question to you for this class is, well, what about the converse of those statements? So if I go back to those 3 statements in red and blue, so if 2 parallel lines are cut by transversal, then corresponding angles congruent, alternate interior angles are congruent, and same side interior angles are supplementary. What would be the converse to those statements? And would those statements be true? That's what today's class is on. So let's see, what would be the converse? The converse is when I leave the words if and then in the same place. So let's see, I take the words if right here, and I take the word then right here, leave those in place, and I swap everything else. In other words, I'm going to swap this statement and these 3 statements down here. So let's see, what kind of statements would I get from that? Well, let's see. So the converse of the first one would be, instead of if 2 parallel lines are cut by transversal, we would start with if corresponding angles are congruent. Well, then the consequence would be that the lines are parallel. And then if alternate interior angles are congruent, then the lines are parallel. And if same side interior angles are supplementary, then the lines are parallel. So today's class is about those 3 statements. So basically, today's class is about proving lines are parallel. And we'll have 3 main ways of doing it. They're right there in red, or right there as if-then statements. If we can prove that the corresponding angles are congruent, then the lines are parallel, lines H and K. If we can prove that the alternate interior angles are congruent, then H and K are parallel. Or if we can prove that the same side interior angles are congruent or supplementary, then the lines are parallel. All right, so today is all about proving 2 lines are parallel. All right, so postulate 11 is that first one. So if 2 lines are cut by transversal and their corresponding angles are congruent, then the lines are parallel. Once again, we don't prove postulates, but if you want a basic understanding, remember, if corresponding angles are congruent, right, then the only way that would happen if H and K were actually parallel to each other. Because if we twisted H or K, if we change the angle 5 by twisting K around, right, then it wouldn't be congruent to angle 1. But if angle 1 and angle 5 are congruent, therefore that only occurs when the lines are parallel. All right, so that's the converse to 10. And you don't have to prove that all the corresponding angles are congruent. You just need to pick one of them, 1 and 5, or 2 and 6, 3 and 7, or 4 and 8. All right, so what would a question look like about that on homework? It might look like this. And remember, this is the statement. If corresponding angles are congruent, then the lines are parallel. So it might look something like this. If you could show that angle 2 is congruent to angle 6, then that only would occur if line L is parallel to line M. So that would be as easy as it gets, where they hand you line 2 is congruent to line 6. But more likely, it's going to be a far more complicated thing. Now, be careful. This one definitely can cause your eyes some problems. So let's see. It says, which lines are parallel? So let's think this through. Which lines are parallel? Well, it looks like it's possible that the following lines are parallel. It's possible that the 2 red lines it's possible that they're parallel. So let's see. If they were parallel, that would mean that this angle and this angle would be the same. And if you can notice, yeah, they're not the same. So that's not true, right? So what about those red lines? What if those red lines, I'll do this in blue now. If those were true, then that means that this angle I'm not trying to make it right. And this angle would be congruent. And in fact, 50 plus 30 is definitely equal to 52 plus 28. So that would mean that the red lines are parallel. So sometimes the picture can be a little bit confusing, right? But it's not too bad. All right, here's another one. Same looking thing. So it says which lines are parallel. So basically we consider which two lines probably are parallel. Probably the two red ones there are parallel. So let's see. If that were true, then that would mean that this angle 61 would be equal to, oh no, they're not equal. So those two lines are not in fact parallel. Okay, well, what about the other ones? What about this one? So let's see, what would I have to do? I would have to add up these two angles. Let's see, 23 and 61 would be 84. And add up these two angles, and that would be 62 plus 22. Hey, that's also 84. So in fact, since we got the same number, those two red lines are parallel. So line H, I, and T, N are in fact parallel. Do you see how I did that? If not, rewind the video, play that one again. Okay. Let's do a proof. All right, so let's see. Here's a proof here. It says we have transversal T that cuts lines K and N, and we're supposed to prove that K and N are parallel. Oh, and we're also given that 1 is congruent to 2. And notice there's a third angle there, 3, that's marked, but it doesn't say anything about it. All right, so that's where we're starting, and that's where we're finished, right? We only have one postulate that shows that two lines are parallel, and that says that if corresponding angles congruent, right, then the two lines are parallel. So that means I need to show that angle 1 and angle 3 are in fact congruent. That's the only definition or postulate or theorem that I have so far. So my goal is to show that 1's congruent to 3, 1's congruent to 3. All right, what am I going to do? What am I going to do? I'm going to look at the picture and see if I notice something. Well, hopefully you noticed it before I said this, but hopefully you noticed that let's see, angle 2 and angle 3 are congruent because they're vertical angles. And now look at what your proof looks like. In fact, I want you to look right here. So if you read those two statements right there, what does it say? It says angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Therefore, 1 is congruent to 3, and that's the transitive property. That's your classic transitive. You could also have put substitution as well, too. All right, so the proof is done, and now we got to think about, well, what did I just prove? What did I just prove? Well, what did I just prove? I proved that if you are told that 1 is congruent to 2, those are alternate interior angles, that the two lines are parallel, and we proved it. So that's theorem 3.5, which states two lines are cut by transversal and alternate interior angles are congruent, then the lines are in fact parallel. So this is the converse to 3.2. If 4 is congruent to 6, then line L is parallel to line M. What would a question like that look like for homework? Okay, here we go. We haven't talked about quadrilaterals yet. We will eventually. So I can't say anything about that being a rectangle or a parallelogram or something like that. I can only talk about the two triangles. So let's see. Let's see, which lines look like they're parallel? So potentially the top and bottom are parallel. Well, let's see. If that were true, then that would mean that, well, it's cut by that transversal. So that would mean that this angle right here would have to equal this angle. Oh, wait, they are equal. Well, that means that the two blue lines there are in fact parallel. Okay. Ooh, what's going on there? All right. Give me 1 second. Something happened here. I know what happened. Some animation went haywire on me here. Okay. Sorry for the delay. All right, so let's see. Oh, I need to make this picture shown. That's number 14, delete 14. There we go. All right, back to this. All right, so let's see. What other two lines could be parallel? Well, could the top and the bottom be, or sorry, left and right be parallel? We showed that the top and bottom are parallel. So turn your heads to the left and notice that the alternate interior angles are not 48 and 48. It would be this number and this hidden number right here that is not listed. So that's our problem. We need to somehow figure out what that number is. How are we going to do that? We're going to use the fact from pre-algebra, the fact that we know that the sum of the interior angles of a triangle equal 180. And notice that triangle, I don't know if you want to call it the bottom triangle or the one on the left. We have two of the angles, 90 and 48. So maybe we add those up, subtract from 180 and do a little bit of math, right? So 180 minus the sum of 90 and 48 is 42. So I know that angle right there is 42. And then finally notice that 44 and 42 are not the same number. Therefore, the two blue lines are not, in fact, congruent. Okay. All right. Here's another. This is a separate problem right here. So let's see. What do we want to consider? We want to consider if you turn your head to the left, is this line parallel to this line? Well, that's the numbers 46 and 44. So those aren't parallel. Maybe the other two are. So the other two would be the top and the bottom. And once again, notice I got 46, but I'm missing this one right here. I'm missing that one. So let's see what that angle is. So that angle would be 180 minus the sum of 44 and 90. And that would in fact be 46. So yes, the top and bottom are in fact parallel. So LA is parallel to TS. That's how those work. Okay. What else is left? I'm going to give you this one for free, meaning we're not going to prove it. You're going to prove it tonight for homework. But this is the one, the last converse. This says that if the sum of the same side interior angles is supplementary or equal to 180, then the two lines are parallel. All right. So if measure of angle 1 plus measure of angle 2 equals 180, then line L is parallel to line M. Cool. So what would this look like for homework? All right, so let's see what we got here. So let's see, should we consider the top and the bottom or the left and right? It doesn't matter which one we do first. Let's consider the top and the bottom. So if this line right here, KC, is parallel to DE, then that means that these two added together must equal 180. Do they equal to 180? Just let's do the math right here. They do, in fact, equal 180. So that means the top, KC, is parallel to DE. Well, what about the other two sides? All right, well, let's do those. All right, so the other two sides would be this side right here and this side right here. Well, that would mean that these two numbers, this one and this one, would have to equal 180. Is that true? Is 118 plus 64 equal 180? The answer is nope. So nope, they're not parallel. So the only things that are parallel are the top and the bottom. Make sense? Okay, remember we had some minor ones. We'll throw those in there as well too. So remember we had the one theorem after the original the main three, which was if a line is perpendicular or transversal is perpendicular to one line, it would be perpendicular to the other parallel line. So the converse of this would be if two lines are perpendicular to the same line, then the lines are parallel. All right. Once again, this is a homework one for extra credit. If you'd like, you can do that for extra credit. So that's our fourth and final theorem of the day. All right. So far to show two lines are parallel, show the corresponding angles are congruent, or show alternate interior angles, show the same side interior angles are supplementary, not congruent. And lastly, the minor one. These are really corresponding angles. In a plane, show that both lines are perpendicular to a third line. Notice we have not talked about alternate exterior angles at all or same side interior angles. I'll do a quick proof just to show you those are true. So let's see, this would be alternate exterior angles. All right, so let's see. Well, if we have two parallel lines cut by transversal, we know that alternate interior angles are congruent. Yep. Well, if you notice in this picture, 5 is vertical to 8 and 1 is vertical to 4. So by the transitive property, if 4 is congruent to 1 and 5 is congruent to 8 and 4 is congruent to 5, then that means 1 has to be congruent to 8. Well, that's a quick talking proof, but that proves that alternate exterior angles are in fact congruent. Turns out you can prove that alternate or same side exterior angles are supplementary as well too. I'll let you do that one all by yourself. Okay, that's it. But, right, some examples, right? Remember, these are the three main ones that we had, right? There's that fourth one. This one causes students some problems at times. I'll show you this one. So let's see. We need to find the values for x and y. So let's see what we got here. So we are told that the top and bottom are parallel and left and right are parallel. Well, if that's true, then these two angles right here, are in fact alternate interior angles, which makes them congruent or equal. So we set them equal to each other and solve for x. So we solve for x, move the x's to one side, move the 20 to the other side, or subtract 20 from both sides, divide by 2, and we get x is equal to 15. Okay, cool. X is equal to 15. Well, if x is equal to 15, let me clear out this first. If x is equal to 15, then I can plug in a 15 for this right here, which means that angle is 65. And these two angles in relationship to the left and the right side, that's AE and BF, those would be same side interior angles. They would be supplementary, which means that those two angles added together, 2y minus 5 and x plus 50, would have to equal 180. And I know that x is equal to 15 from the previous thing. So it's just a bunch of algebra at this point. 15 and 50 is 65. 65 minus 5 is 60. See what I did there? Subtract 60 from both sides, 120. Therefore, y is equal to 60. Cool? All right. Basically, the last thing of the day, or the last concept of the day, there's a couple things here, is the following. This is different than what we've done so far. So think about this. This is going to be theorem 3.8. And it says if you have a line and a point not on the line, that there is only one line that you can draw through P that is parallel to K. I'll say that again. If you have a point and a line where the point is not on the line, there's only one line that you can draw through the point, that's point P, that would be parallel to the given line. And that's what theorem 3.8 says. All right, I'll give you a proof, right? Let's see. If that was true, right, and I drew a transversal right here, then that means that this angle right here and this angle right here would have to be congruent, yeah, corresponding angles. But if there was a second line that you could draw through P, this is definitely not parallel. But if there was another line that was parallel, then maybe that's that one right there. Well, that would mean that this piece right here would need to be added to this measurement right here. And clearly that would not make it equal to the original angle right here. Well, that's particularly why there is not another line that you can draw through P. In fact, there's only one line through P, and we drew it, that is parallel to line K. This is called a hand wave proof. A hand wave proof is where I just really briefly talk you through the proof itself. All right, theorem 3.9 says the same thing except for perpendicular lines. It says through a point not on a line, there is one line through P that is perpendicular to line K. All right, I'll give you another quick proof of this. If I draw another line through P that goes to K, if that was 90 degrees as well, if it was perpendicular to the line K, if there was another line, then you'd have a triangle where two of the angles equal 90, and that can't happen. You can't have two angles of a triangle equal 90, not on a flat plane. So that was a quick, another hand wave proof of this one. All right, last one. Okay, let's see. I don't have two lines, I have three lines, right? And it says the following. It says if two of those lines are parallel to a third, if K is parallel to L and N is parallel to L, then all the lines are parallel to each other, right? I'm not going to give you a hand wave proof on this one. This is pretty straightforward. All right. So in summary, right, to show that two lines are parallel, show the corresponding angles are congruent, or alternate interior angles are congruent, same side interior angles are supplementary. In a plane, show that both lines are perpendicular to a third, right? Show that alternate exterior angles are congruent, or show that lines are parallel to the third line. Those are all ways to show that lines are parallel. So that's 6 of them that you could use on homework. So as you're doing your homework tonight, which is right here, right here, have the book open so that you can look at those theorems when you read them as you do them. As always, if you run into any problem, don't hesitate to ask me, and I will see you in the next class.